Good afternoon, everyone. Welcome to Here's the Execution Plan. And now what? My name is Hugo Cornelis, and I make SQLServerFast.com. Yada, yada, yada. A lot of talk about my website, where I have everything you will want to know about execution plans. The one thing I need to put up, I'll try to keep this as short as possible because I only have 50 minutes, is the code bits24 that until half May will give you a 10% discount on my paid codes. Of course, there's a lot of free stuff on my website as well. So more about me, more self-advertisement. The only thing that's really relevant about me is my email address and my X handle, where you can reach me if you have questions after the sessions. If you have questions during the session, you can just raise your hand, and if I don't see it, shout something, preferably something insulting. That usually means that I will think you're addressing me. Questions from the online audience. Hi, nice to see you here. I don't see you, but you see me. You can type your questions in chat, and these friendly people up front here will then interrupt me and ask your questions on your behalf. So, with that out of the way, let's get started. Let's talk about what I'm going to do in this session. I teach about execution plans a lot. And most of the time when I talk about execution plans, I am the teacher, you are the pupils, you are watching in awe as I present my carefully crafted demos that nicely demonstrate a nice, simplified execution plan that focuses on the one thing I want to talk about, and then I talk and jabber on and on about everything you can learn from that execution plan, and you look at it and you think, I learned something today, now I am smart, now I can impress my coworkers. And then the next day you arrive at your work with your newfound knowledge, and your boss says, you were at SQL Bits yesterday, you learned about execution plans. Now go help your coworker who is stuck with a performance problem. And you say, yeah, I can immediately apply my knowledge. Let me see the execution plan. And then you're like, oh, that's not what Hugo showed yesterday. No, it isn't. So I'm not going to do this today either, but I'm going to sit somewhere in the middle. My idea is to bridge the gap between those simplified classroom examples that are ideal for teaching the basics and the messy reality. I see a few people standing. There are some seats over there and a few seats here up front, so you can still sit if you want to. So this is designed as a 75-minute session, and I am infamous for always going over time, so I will not be able to do everything. I have 3 separate cases here, 3 separate demos, and I know from experience that the first one on excessive I/O will probably take the entire 50-minute session I have, or we can skip that one and we can then do demos 2 and hopefully also demo 3. I will leave that up to you for the record. You don't have to miss anything. There's a tiny URL link there that leads to my YouTube channel where you will find videos of all 3 of those cases. So you can check what I don't have time for now on my YouTube channel later. But I want to see a show of hands. Who wants me to spend time on a scenario of excessive I/O and probably not have time for the rest? It's just a few. Who prefers to have me spend time on high resource semaphore weights? Quite more, and then we'll hopefully also, and who thinks I should start with the erratic query performance? I think the resource semaphore weights are the highest, so I will just jump to that demo. And we'll see how much time I have left when I've finished that demo. So, to start with, high resource semaphore weights probably baffles some of you already, because what the bleep is a resource semaphore weight anyway? Let's start there. SQL Server has its own memory management. When you run a query that requires a lot of memory, what happens is that SQL Server will first ask for memory and reserve that memory. If that memory is not available on the server at that point, it will have to wait. For some reason, Microsoft decided to call that a resource semaphore wait, because if you would call it a wait for memory, then everyone would know what you're talking about. And it's not our intention to make our lives easier, right? So resource semaphore waits basically means your queries ask for more memory than the server has available at this time. And that is a problem we have here. So the system is often slow, and what is happening here in this scenario is the company has a dashboard application. You know those sales departments when there are screens hanging all over that constantly refresh with the dashboard of the best sales of the last hour. This is such a company. So they have a query that is constantly refreshed on all the screens throughout the company to show the top sales. And the sales managers also can bring up that report themselves, and they can then paginate further to see whether they are perhaps on page 2 or page 3, and they probably have a click-through function as well. The problem we have here is that the stored procedure called paginated sales report, which runs hundreds of times per 10 minutes or per whatever time interval, it runs a lot because all those screens refresh all the time and all those sales managers are constantly hitting F5. That stored procedure requires a high amount of memory in relation to what the server has available and in relation to how many copies of that stored procedure are constantly executing. So we need to fix that. And if we just look at what the stored procedure does, I can run it, and you will see that it returns some results, 20 rows total, that's all. The results are not really what I care about right now. I care about not the performance, but the memory usage. So let's enable the execution plan and run it again. And when it comes back with an execution plan, I can look at the top left and I see that the memory ground is 47 megabytes. Now that is not a lot, because I'm demoing in AdventureWorks, which is a very small database. So let's imagine that I were doing this on a real database with real data, and let's imagine that hence the memory ground would be an actual number that we are afraid of. And let's imagine that 47 megabytes times the number of users is actually causing the server problems. So I'm going to request you to use your imagination a bit. Whatever the reason, the memory ground of this query is too high for how often the query executes. Now what I need to do is first look at the stored procedure. So I'm going to look at the stored procedure. And that would be in AdventureWorks, stored procedures, paginated sales report. There we go. And I always click modify because that's one mouse click less than script as create to new query window, and it does the same thing. So we see it is a stored procedure that accepts a parameter, but the parameter has a default. So in the problem code, we see that there is no parameter used, which means the default applies, and we run with page num equals 1. And what does this query do, this stored procedure do? Well, the comments aren't helpful because they aren't there. I don't normally write code this way, but when I'm called in at a client, it's not code I write. This is reality. Sometimes you have to work with code that is not commented. There's one thing worse than code without comments, and that is code with outdated comments. How many of you have seen that? Almost every hand goes up. You look at a comment, you think you know what the code is doing, but then turns out someone changed the code and didn't update the comments. Woohoo! Anyway, at least we don't have that confusion here. Here we know that we're on our own. So I have to look at the code, and it creates a temporary table called all results. Then there is an insert into that temporary table. using a CTE that aggregates some sales data from sales order detail and sales order header, quite standard in AdventureWorks sample queries. And then those aggregated sales data are joined against various other tables because based on the product ID, we want to drag in the product number. Based on a special offer ID, we want to drag in the discount percentage. Based on the customer ID, we want to drag in the last name, and so on. That data is then stored into the all results table, temporary table. And then there's a next query which simply returns data from all results based on a row ID between two values computed from page num. And the default page num 1 times 20 minus 19 is 1, and 1 times 20 is 20, so this is between 1 and 20. The row ID is not listed here in the insert statement, which is a bit weird. Where does this row ID come from? Well, if you look at the table definition, you will see that it is an identity. And that also explains why in the insert there is an order by. Normally an order by in an insert is ignored because SQL Server will insert it in a basically unsorted bag of data. But when you apply an order by to an insert in a table with identity, then those identity values will observe this order by. So those row IDs are based on a descending total order quantity, and the default invocation of this store procedure then returns rows 1 to 20, so the 20 top sales, which is what we already knew, but now the code confirms that this happens. Cool, we know the code, but now we need to figure out why there is so much memory usage. So let's return to the execution plan. I already had the execution plan here. We have looked at this memory grant of 47 megabytes. And now the problem is these 47 megabytes are because of various operators within the execution plan. And here you need to know what operators use memory. Well, if you don't know that, you can use my website, the execution plan reference, because that gives you that information for each operator. I happen to know that a sort operator is an operator that uses a lot of memory. A hash match operator is also an operator that uses a lot of memory. And in this execution plan, there are quite a lot of hash match operators. All other operators in this execution plans do not have an excessive memory usage. Now, a problem with the memory grant is the execution plan only gives you the memory grant for the top left operator. I want to know which of these memory using operators is mostly responsible for that 47 megabyte memory grant, but there is no easy way to get to that information. However, what we can do is look at the estimated input for those operators. The hash match aggregate, well, sometimes the input, sometimes the output. The hash match aggregate stores its output in memory. So for the hash match aggregate, I have to look at the estimated output, and there we see that the estimated data size of the output is 3.5 kilobytes, 3.5 megabytes. Okay, cool. I can do the same for this hash match join. For a hash match join, the size that is needed in memory is the top input. All those things are things you need to know or find on the execution plan reference. And here we see that the size of the input is just 290 kilobytes. So this hash match doesn't factor in quite a lot, is not really relevant. This hash match then has an estimated input of 1.2 megabyte, also not the big problem. And we can keep checking hash matches that way. And then we also have the sort, which stores its entire input in memory. And in this case, I'm ending on the sort because I know that this is the biggest contributor. The 12 megabyte is the biggest contributor to the total memory grant. So if I want to reduce the memory usage of this query, I have to do something about that sort. That's an issue because functionally we need the data sorted by the total sales, because how else do we get the top 20? Now at this point it helps to understand your application. Like I said, This is a dashboard application. There are all those monitors that are constantly refreshing on page 1. Many users will also regularly refresh page 1, and sometimes they will request other pages. And you can set up tracing or other ways to count it, but in this case I already know, because I know the company, that out of every 1,000 executions of this store procedure, 999 will be for the default page number 1, and just 1 will be for another page number, on average. So I decided perhaps I can find a way to tune this query for those 999 executions and just accept that the one execution with a different page number still has this high memory grant. Because the problem is not that this query has a memory grant once, the problem is that this memory has this query has this memory grant, and it executes hundreds of times, so it has multiple copies all at the same time, and that adds up. If most of those copies don't have the memory grant anymore and just one of them still has it, our server can handle that. So I am going to try to find a way to tune this query to get a lower memory grant. I don't care about the rest, just the memory grant, because that's the problem I need to fix for page number 1. And that is where I hope that I can use a different version of the sort operator. The standard sort operator will sort the entire input and then return the entire input, which, as you see on the screen, is 120,000 rows. So we're collecting 120,000 rows of data, sorting them, then returning all 120,000 of them to store them in a temporary table, and then return just the first 20 rows. What if we sort 120,000 rows and then return just the first 20 without putting anything in a temporary table first? You might think that's the same thing, but SQL Server has a different version of the sort operator, which is called top n sort, which is actually optimized to use far less memory if the value of n is below 100 or below 127. I always forget what the threshold is, but there is a fixed threshold. 20 is definitely below that. So if I can find a way to make SQL Server use that top n sort for the top 20 rows, then hopefully my memory grant will be less. So let's try to make that happen. So in order to do that, I already recognized I don't care about the performance for page number 2 and up. And I don't care about the memory grant for page numbers 2 and up, because those are just a handful of executions per day anyway. So I now have a new version of the store procedure where I have 2 code paths. And I'll skip the first. If page number is 1, then the else, that is just page number 2 and up. This is just a copy of the old code. I didn't change anything. I didn't even bother to add in a comment. Perhaps I should have. But I have a bunch of tickets that are all waiting for me. I want to get this out of the way as fast as possible without spending time on things not covered in the ticket. So this is just a copy-paste of the existing code for everything, but now it will be only used for page number 2 and up. And here is a new version of the code that is mostly the same, but there is no insert into here, there is no temporary table. I just use the same CTE, and then use the same select with some joins and add a top 20 here. So now I tell SQL Server, just aggregate the sales data, join to everything, and then give me the first 20 rows based on descending total order quantity. And only do this for page number 1, because for the rest, I do need something else. So I'm going to create this new version of the store procedure, and let's see whether, bless you, it helps. Of course, I still get the same results. I should check that they are correct. I did check that when I built this presentation. I'm not going to spend valuable time on that now, but trust me, I always do check that I get the correct results. And you see that the execution plan looks very different now. The first thing I want to know is, what is the memory grant now? So I'm going to hover here, and yes, we reduced our memory grant by quite a lot. Perhaps this is already enough. Perhaps it isn't. I don't know that yet. But I do know that I found some success. However, the weird thing is, if I scroll to the right, you will see that there still is a regular sort. And there's even a warning on the regular sort that says, oh, I spilled data during execution, so I actually needed more memory than I had. So I reduced the memory grant, but a bit too much. And because I'm running on SQL Server 2022 with a memory grant feedback enabled, if I simply execute the query again, I expect the memory grants to be a bit higher again. Well, it's not. So I'm not sure. Perhaps I have a database compatibility setting left from a previous demo that disables it. I'm not going to figure out why. Anyway, the memory grant, even after memory grant feedback kicks in, will still be lower than the 49 megabytes we had before, and the spill would normally be gone. But what I wanted to focus on is that we still have the regular sort, and not the top-end sort. And yet the sort only returns 20 rows out of 21 estimated rows, which is already weird. Why did we estimate 21 rows here? And why did we only return 20? Well, that is because all the way to the left is the top operator. The top operator says, give me 20 rows. And here the estimate is 20. And that estimate of 21 to the far right already gives away a bit why this is happening. Here we have all those joins. And now they don't use hash match anymore for the joins, which is the reason of the reduced memory grant. So I tried to get rid of the high memory grant of the sort, and I ended up getting rid of other memory grants. Some sort of success, but unexpected. But I still didn't get it the way I want, and the reason is that SQL Server says, looking at the code, you want 20 rows in your final result. That's here. You want 20 rows in your final result. The final result is based on using the aggregated sales data and then joining to all those other tables here. Some of those joins might not have a matching row. So if I start with 20 aggregated rows and then do the joins, I might end up with 19 in the results. Some of them might have a duplicate, so I might end up with 21 rows. Now, if I had trusted constraints in my database, then the optimizer would know better. Because I know that this data is all correct, is all relationally correct. We're joining on the key column. There are no orphan rows. Every row from the aggregated sales data will join to exactly one product, exactly one special offer, exactly one customer, and exactly one person. But apparently the optimizer didn't know that, and the optimizer has to make sure that there are 20 rows in the final result set. And that might take 22 or even 2,000 rows from the aggregated sales data in theory. Now, ideally, we would change the application, change the database schema to make sure that those constraints are there. They should have been there all the time. But we don't always have that level of control. Sometimes we are not allowed to add constraints or to change the database schema in any way. So let's assume that in this case, I am not at liberty to add those constraints. I still want to reduce the memory grant even more. I still want that top-end sort. So here is where I'm going to tell SQL Server, hey, you know what? I understand that you don't dare to take that chance because you are in deep trouble if you don't return 20 rows. But I am going to take over that responsibility. So there is a new version of the code here where I say, just give me the 20 best aggregated sales rows and then join to the rest of the tables, and I don't care how many rows there are now. I know it will still be 20 because I know that in this case the application is correct, the data is all correct despite the lack of constraints. SQL Server doesn't know that, but now SQL Server doesn't care anymore. Now SQL Server is correct in the results if the final result is 19 or 21 rows. So in this case, I do take a risk. if an error in the application causes something to go wrong with the data, there might be 19 or 21 rows in the results, but I am willing to take that risk to see whether it helps. And if I run this query and look now, you will see that the memory grant is now reduced to 14 megabytes, which is a lot lower than the 49 we had at first. We also see that there is no top operator here anymore, and that if I go to the right, SQL Server has indeed combined the top and the sort into a top and sort. Now the remaining 14 megabytes are here for this aggregate hash match aggregate. Getting rid of this is a lot harder, and I'm not going to go into this in the scope of this event, of this session. And that is not just me avoiding the hard stuff, that is also a bit of realism. Of course, when I see a query like this, my fingers itch to get the memory grant even lower, to make it faster, to make it better. I want always to improve. But like I said, the reality is that I still have a whole stack of open tickets that are actually important to the business. At 14 megabytes, even when all dashboards refresh at the same time, the server has enough memory that there will be no resource semaphore waits anymore, and that those queries will just finish fine. So the problem is solved. Optimizing something that isn't a problem can be nice for your feeling of self-esteem. And if you're running on Azure, it might even save the company money, because there you are paying for resources. But if you have a whole stack of tickets, you might want to prioritize them first. So yes, there might be options. They will be harder, but there might be options to do even more with this query. But at this point, I need to put this query aside, check this in as I have a solution, put it into test, make sure that it follows the right channel until it is deployed, and I can move on to the next problem. And we do indeed still have time for the next problem. Yes, question?
Yes, I think in the select part where you join the CTE with your other tables, wouldn't you still have to put in the order by there? I think it's going to logically find it out. But
the question is, do I still have to include the order by in the select part after the join? Let's look at the query. And I need to look at the optimized version. So the order by has now been moved to the CTE because it needs to match the top. Otherwise, SQL Server doesn't know how to interpret the top. But that means that there is no order by here anymore, and SQL Server is free to return the rows in any order it wants. You are right, you found a bug in my code. My compliments, I had never noticed this. The way this query works and the execution plan works, it will not change the order. That's because I know how this execution plan works. But that is relying on undocumented and unguaranteed behavior. And if one of my developers would do this, I would slap them. So once I am home, well, let's do it now. Thank you. I deserve that because there should have been an order by here. It would not affect the execution plan at all because the optimizer knows I do not need to reorder those rows, but then the optimizer also knows I cannot change the execution plan in a way that is a bit faster but reorders those 20 rows. Very sharp. This is the first time someone found that error in my presentation. I know I have a lot of crappy code in this presentation on purpose, but that's the start of it. The end should have been supposed to be better. My apologies. Are there any questions from the online audience? Any more questions in the room? Then I do indeed have time for the next demo, which is the problem of erratic query performance. And I assume that some people in the room will now think, oh, this is going to be about bad parameter sniffing. You are not wrong. It isn't always the case, but erratic query performance, if the same query sometimes is fast and sometimes is slow, and there is no discernible pattern in when it is slow and when it is fast, is very often, note that I do not say always, but very often caused by bad parameter sniffing. But let's look at this specific example and also look at how we are going to fix this. So, in this case, there is a stored procedure called find orders that is used to, well, find orders. And users complain about erratic query performance. Sometimes it's fast, sometimes it's slow. They have no clue what the pattern is. And of course, they blame the database because it's always the database. And hence, they blame me, and I need to figure it out. So let's make sure we're in the right database. And this is a stored procedure that actually takes parameters. So I'm going to fill in the parameters with some random values just to see what the stored procedure does. So let's put in a sales order ID. Let's put in an order month, character 6. Who designed this? That's a very bad way to do it, a month, but okay. There's also a ship month. Let's put that at the same month. Then there is a salesperson ID. And let's leave the rest of the parameters at the default, because there's defaults for everything. Yes, thank you. Let's make sure we get an execution plan, and let's execute this. No data, okay, I probably put in some values that do not exist. I don't care, I care about the execution plan. Now I see an execution plan here, okay. Not sure whether the problem is here. Because what I also am going to do when I see that there is erratic query performance, that is often a case where a query store can help. So in this case, I know that it would not be the report I normally use for this, but in this case, I know that in my demo, I can find it as a top resource consuming query. So this is a high resource consuming query, and you already see in the right top pane that there is a bunch of different execution plans, and they also have a high variance in execution time. You already see them at different heights in the graph, but if I hover, you will also see that, for instance, this execution plan has a minimum duration of 6 milliseconds and a maximum duration of 300 milliseconds. That's a high variety. This execution plan, that at first sight seems to be the cheaper one, has a minimum duration of 3 and a maximum of 126, which is also too high. So all of these execution plans have a high variety in their execution time, and none of these execution plans are actually ideal. And the one thing I note is that all of these execution plans start with an insert and then a clustered index insert operator. And that is weird, because you see the clustered index insert every time in every execution plan I click. But if I go back to when I executed the query, there is no clustered index insert here. That's weird. So perhaps we should once more look at the text of the stored procedure. Find error orders, modify, and here, oh, we have comments. Let's hope they are correct. And if I read the comments, and in this case, it turns out they match with what the code does, they say, we find orders based on the supplied search parameters. So this is one of those infamous stored procedures that you can use to find to look for Bentley's, Whitney Houston, and Switz. And there is apparently a special case. If a sales order ID is given, then there is one is not given, is null, then there is one code path where we create a table variable, insert something in that table variable based on all those standard patterns of sales order ID is null, or sales order ID matches the parameter. Order month is null, or order date matches the parameter, and so on and so on. and then return data based on a join with a selection of sales order ID is in that table variable. But there is also somewhere, no, I see it. So there is a special code path for sales order ID is null that populates this table variable. That part is skipped if sales order ID is not null. And then in both cases, we have a final query that returns data based on either the sales order ID is the supplied parameter or the sales order ID exists in the table variable, which is only filled if sales order ID parameter was null. But then, so it's always either of the two, and this actually does what we want to do. When the sales order ID is supplied, we basically ignore the rest of the parameters. And that is why when I tried to just execute the procedure with some random parameters, I supplied a sales order ID. So SQL Server simply ignored the rest and said, oh, you want sales order ID 1000. Didn't happen to exist. So apparently just putting in random parameter values didn't replicate the problem. So we just look in the ticket or we ask some users to give us some specific use cases where they recently had bad performance. And that results in a product ID and a ship month. If we search for this, then we sometimes have good performance and sometimes have bad performance. Here, if I look at the execution plan, I see that I actually get two execution plans. The first one has the clustered index insert that we recognize from the queries in the query store that were indeed erratic in their performance. And the second one matches the one we already saw. And this is not the one causing the problems. There's no erratic performance on this one. I won't show it now, but you can try to find this query in the query store and you will see that it has a more or less predictable performance. This query is the one that's causing the issues. And we already saw it has 4 different execution plans, and each of those execution plans has very different execution times, which indeed confirms my initial thought that this might be bad parameter sniffing. There's another way to get that confirmed, and that is to look at the properties of the top left operator, to be specific at the parameter list property. So there's a whole list of parameters here, and you can look at each of those parameters, and you will see that there is a compile value of null and a runtime value of null. So this parameter is not the issue today. But for the product ID, the compile time value is null, and the runtime value is 709. So this was compiled for a case when some other parameters were given, and the execution plan is optimal for that case, but not for the rest of the cases. So let's take a step back and look at the problem of bad parameter sniffing. Bad parameter sniffing is caused by an unlucky combination of 2 things that both are good. One is caching and reusing execution plans. We want SQL Server to cache and reuse execution plans because otherwise there would be way too much compilation overhead on our systems. The second is parameter sniffing, and we want SQL Server to do parameter sniffing because most of the time it gives us better execution plans. Most of the time. But sometimes we sniff a parameter, we get a good execution plan for that parameter, we store and reuse the execution plan, and then the next parameter or set of parameters is different, and now the execution plan is not optimal for that set of parameters. But we keep using that execution plan until something happens, and there's a whole bunch of reasons that can make it happen, that causes SQL Server to recompile the query, and then we get an execution plan that is optimal for a different set of parameters, which explains why suddenly good performance changes to bad or bad performance changes to good, depending on what parameters you put in. There are multiple cases that can happen. There are 3 main contenders for problems with bad parameter sniffing. One is filtering on a heavily skewed column. For instance, you skew on the city where your customers live, and you are the London Herald. So 99% of your customers live in London, and 1% of your customers live in the rest of England and even worldwide because they have some interest in London news and want to be subscribed to the London Herald. That is very skewed distribution, and if you're searching for customers in Dublin, that will be just a few customers, and you get an execution plan that's optimized for that. And if that execution plan is then reused for customers in London, you're using an execution plan that is optimized for just a few customers on all 2 million London customers you have. That is not going to end well. The second reason for bad parameter sniffing is when you have range queries. For instance, a report of the sales from a specified date until now. If that is almost always used for last week, then you have a small sample of your entire sales database that you are processing. But if then one day a manager says, I'm going to use that report for an overview of all the sales since 2015, then a query optimized for just the last week is going to be used on a data set of almost 9 years. Again, you are going to have bad performance. Unless the sniffed value happens to be when the manager runs for 2015 and up, but then all your sales managers who ask for the last week will get worse performance because they are processing 1 week of data with a query optimized for 9 years of data. And the third common problem with common cause of bad performance, bad parameter sniffing, is what we saw today, a store procedure with optional parameters. This store procedure was, the last time it compiled, optimized for, I don't know, I didn't check all the parameters, but a specific set of parameters, and it is now called with a different set of parameters. And SQL Server will still give us the correct results, but using an execution plan that was optimal for a completely different set, and that is why we get bad performance. So I can clear the cache, get a new execution plan for this set of parameters, and then it will be faster. But then a different call will be slower again, which is what I have in the demo here, but I'm going to skip that part, because I want to, because that isn't a real fix. If you run this at home and you will need to change, if you run it at home, you will need to change this value with whatever comes from this query. And then you will see that the same query suddenly gives you a much better execution plan, but then this query will give you a bad execution plan because now we are running with something optimized for product ID and ship month, and we're trying to filter by last name. So there is no silver bullet here, and we need to find a way to fix this. Now in the comment I have several standard ways that can often be used to fix bad parameter sniffing. And I am personally, when it is possible, I like to just use the option recompile hint. And not every expert agrees with me on this. The important part in my advice is where it is possible. Do not forget that. If a query runs 100 times per minute, then with recompile will thrash your production server because of the high CPU overhead. That is a case where it is not possible. But if a query with erratic performance executes just once or twice a second or so, or even less, and once or twice a second can be a lot if it's a very complex query, but depending on the total of query complexity and how often it runs, there are many cases where, okay, this query will now recompile 200 times a day, and every one of those recompilations will take 200 milliseconds. 20 times 200 milliseconds, so what? So in those cases, this is an easy way to fix it. An option recompile will always give you an optimal execution plan for that set of parameters at the cost of that recompile. If you cannot afford to do all those recompiles, then it gets harder. Then you can, for instance, use optimized for a known or optimized for a specific value. Depending on what problem you are trying to solve, it might help, it might not help at all. And the help here is not specifically giving you the best performance, but giving you consistent performance, which for most users is way more important than the best performance with a risk. Sometimes you can use separate versions of the stored procedures. For instance, for the London Herald, you could say I create one stored procedure to search for London customers and a different stored procedure to search for customers in any other city. Because any other city would probably all benefit from the same execution plan that just uses a tiny percentage of our customer base. And the London customers probably needs a different execution plan that benefits from that optimally processes 90% of our customer base. In the case of optional parameters, that might result in too many different versions. Here we have something like 6 optional parameters. So if we want to cover all versions, we have to have one with 0 parameters supplied, the first parameter supplied, the second supplied, the first and the second supplied, the third supplied, the first and the third supplied, the second, and so on. That would be like 32 different stored procedures. That's not manageable, especially if we later have to change the code, because then we have to change it 32 times. It might be relevant to look at are there 4 or 5 use cases that are most of the time used, create specific stored procedures for those 4 or 5 cases, and then use the generic stored procedure with its drawbacks for the remaining cases. That is a practical solution. And then you can also use dynamic SQL to build a query on the fly. That also doesn't solve all problems. It typically helps very well in cases like this one, where you have optional parameters. However, you have to do it the right way. If you write your dynamic SQL the wrong way, then you open yourself up to SQL injection. That is, I can't believe that this is still a thing, because we have been warning for 20 years about this, but it is still a thing because people copy and paste bad code samples from the internet, because people learn from people who don't teach adequately, and all the hackers know this. So if your system is vulnerable to SQL injection, then the question is not whether a hacker will invade you, but when a hacker will invade you. Don't make that mistake. So in our case, we have chosen to say we're going to create one specific stored procedure just for sales order ID is null. We already had that as a special case. And then for the other 6 parameters, we're going to use dynamic SQL. So I'm first going to create 2 new stored procedures, and there's a drop if it exists just for certainty. One that searches on sales order ID only, and that simply does a where sales order ID is sales order ID. Let's create it. And the second does the dynamic search, and here you will see that all the query text is coded by me. All the parameters like ship month are not included here. I don't add the value here, I add the text ship month here, and I do the same for all the other parameters, and I pass them as parameters. I do not insert the value of any parameter in the query text, because that would expose myself to dynamic SQL, to SQL injection. So I'm going to create that version of the stored procedure, and then the original stored procedure will be replaced by one that calls either of the other 2. And now, and I don't have time to show this all anymore, but you can run several test cases and they will all get their separate execution plan. But if you then run another test case with the same parameters, salesperson ID, customer last name, and different values, the plan will still be reused. So you don't get thousands of execution plans. You get at most 32 execution plans for the 32 possible combinations of parameters. You're still vulnerable to some kinds of other bad parameter sniffing, for instance with data skew. That problem is not solved, but here the problem was the optional parameters. So we fixed the issue. And the comment, and there's comments like this in the other code as well, indicates that yes, there are still issues that you could fix. There are still weird things in the execution plans and in the query, and you can still create backlog items for, hey, if we ever have time, we should look at that. But we are out of time now. I see you handling the things, so I make a nice segue. And we are out of time, so I'm going to close this ticket because the actual issue that the customers had, that the users had, has been solved. And that is the reality of our day-to-day work. We cannot always fix all the errors and fix all the issues. We can often, using execution plans, find the culprit of why performance is slow, fix that to get it to an acceptable level where the users are happy again, and then move on with our job. And if there is more optimization possible, make backlog items, use it for filler work if you're ever low on work, as if that ever happens, and that's it. So if there are any people who have questions, I will gladly take them outside. I will first make sure that I make room for the next speaker. I thank you for your attention. Please do not forget to fill out the feedback form to give me information on what I can do better, to give you a chance at winning awesome prizes, and to give one of two awesome charities of your choice a small contribution on behalf of SQL Bits for every feedback form that is filled out. Thank you for your attention. My name is Hugo Cornelis. Goodbye.